Hi Tina. Why the gloom face, when it's such a sunny day outside? What's troubling you?
Hi Bob. I'm just having some issues with work.
What's the matter? Maybe it's something that I can help you with.
I'm trying to find an estimate for the force of mortality, but the binomial distribution isn't appropriate for my problem. I don't know what to do.
Have you tried using the Poisson model?
The Poisson Model? I don't know anything about the Poisson Model. Can you teach me?
Of course, I can. The Poisson model is a discrete distribution used to model the number of rare events that occur during a specified period of time.
Rare events? What do you mean by rare events?
Such as the number of telephone calls that enters the system in a given minute.
So we can use the Poisson model if the probability of the phenomenon happening is constant in time or space?
That's correct. Because the model can only take positive values, we as actuaries use this distribution to model the number of deaths that occur in an investigation.
This model is exactly what I need. I need to model the number of deaths that occur in an investigation given time exposed to risk, or of the waiting time.
That's great. After you use the model for the investigation, it is then used to estimate the unknown force of mortality.
How do you estimate the unknown force of mortality?
This is done by finding the maximum likelihood of the estimate of the distribution with respect to a constant. This will be the same maximum likelihood estimate as the two-state Marcotte model.
That's handy to know. How is the model measured?
It is measured on annualized basis and is the instantaneous rate of mortality at a given age.
It's such a great model to estimate the force of mortality. Why don't we just use the Poisson model?
Even though it is an unbiased estimator and is asymptotically normally distributed, it has its limitations.
What are these limitations?
Well, firstly it allows a non-zero probability to occur for more than the total number of deaths observed in an investigation. It assumes that the mean number of deaths over the investigation is the force of mortality, which is a constant, multiplied by the exposed to risk. The Poisson model assumes that the central exposed to risk is a fixed amount. Finally, it also assumes that the force of mortality is constant between all ages.
How can it assume the force of mortality or the instantaneous rate of mortality at a certain age be constant? How can we use this model then?
The limitations can be taken into account in the observational plan to make it a good model for an approximations.
How can you carry that out?
One can continue the investigation until the waiting time reaches a predetermined level or value. One more adjustment is to replace each death with an identical and independent life at the exact moment of death. This keeps the population size constant.
Can that always be carried out?
The model doesn't perfectly mirror reality, but we can make certain adjustments to try to replicate reality as much as possible. It is definitely a better model compared to the binomial when representing the mortality process, and it can also be extended to deal with multiple decrements.
Thank you so much, Bob. You really helped me with my work. I should know about the Poisson model since I've completed the CT4 course.
No worries, Tina. Always happy to help. We better get back to work. The force of mortality isn't going to calculate itself.
That's true. I'll see you at lunch then.